do our conic sections with our hyperbolas, not hyperbole. Hyperbole is what you discuss in your English classes. This is a hyperbola. Now, conic sections, we talked about them. If you have a cone and you slice it horizontally, you get a circle. You have a cone, you slice it at an angle, you get an ellipse. If you have two cones stacked one on top of another and you slice through vertically, that's how you get a hyperbola. It has two curves to it, not just one. Now, the general equation for a hyperbola should look fairly familiar. It is very similar to an ellipse with a couple of important differences. Center still h and k. So x minus h squared over a squared minus y minus y minus k squared over b squared is equal to 1. Still equal to 1, but notice it is a subtraction instead of addition. That's what separates the equation for an ellipse from the equation for a hyperbola. It is minus for a hyperbola. Now the A and B are slightly different. So your A and B come from the distances from the origin out to the edge. There's A, there's B. And what you do is you measure out from the origin your A and your B. And I'm going to pause for... Okay, starting back up. So our A's and our B's go out just like they did for the ellipse, only it doesn't give us the edge of the ellipse. What it does is on the end of, in this case, the A's, those are where our vertexes is. Vertexes are, and you draw a box. The diagonals of that box are your asymptotes for your hyperbola. Your hyperbolas are asymptotic to those diagonal lines that go out. Okay? So what you do is when we go to graph, and we'll do this when you graph, you find your center, you go out your A and your B, make the box, and your diagonals go through the box are your asymptotes for your hyperbola. Your hyperbolas are asymptotic to those lines. They never cross, never touch. They do approach and essentially become those lines really far out, but those are asymptotic. Now, you'll notice the direction of our hyperbola. They go out horizontally. This is because we have x squared. If we have y squared, still over b squared, minus x squared, still over a squared is equal to 1, then those open up and down vertically. If your y is in front, it opens up and down vertically. If your x is out in front, it opens up left and right horizontally. So you do have to pay attention to which one is which. It does make a difference which one comes first, the x or the y, because it is subtraction. It does make a difference which one's first. Okay? Questions so far? Yeah. Y goes up and down, x goes side to side. And it kind of makes sense when you think about it. What does your x-axis do? It goes out side to side. X is first, it goes out side to side. Y goes first, it goes up and down, just like the x-axis goes up and down. So it's not that hard to remember, but you do have to know there is a difference which one's first, which one's second, which one's plus, which one's minus. Okay? With an ellipse, because you're adding, it doesn't really technically make a difference which one comes first. Standard form, x squared followed by y squared. But with an ellipse, with a hyperbola, it does matter which one comes first, which one's positive, which one's negative. Okay, okay, let's write some equations. Okay, the first ones are nice because they're centered on the origin. So our h is 0 and our k is 0. So we're going to have x squared and y squared. Okay, so the first one says, hey, our centered at the origin, our x-intercept is plus and minus 4. What that means is when we graph it, centered on the origin, we cross at plus and minus 4. 4 and negative 4. Which tells us the distance of our A. Our A is 4. Okay? That gives us our A. So we have our H and our K, which is 0 and 0. So we know we're going to have, and because it opens side to side the way it's worded here, we have x squared over 4 squared, which is 16, minus y squared, and we have to figure out what b squared is. My notes. I made a mistake on my notes. Not that you know, but I just figured that out. Okay. So, how do we figure out what our B is? This is where it gets interesting, and this is everything for that. Okay. Yeah. Our asymptotes, remember, we have a box that goes like this, and our asymptotes are the diagonals through there. Right? That's our graphing situation we have. On our asymptotes, one of our lines for an asymptote, one of them is y equals 5x over 2, which is actually this line here. Well, the asymptote goes through this corner. This corner is the point A, B, because I go over A and I go up B. That's the point A, B. So if I know the x coordinate, the B is the y coordinate from that asymptote. My A is 4. I plug in 4 for x. Y equals 5 times 4 over 2. I know that that corner is the point AB. That point AB is on the line 5x, y equals 5x over 2. Plug in the x coordinate, the A, to get your y coordinate, the B. So I end up getting y is equal to 10, and that's my B. So what do I have down here? I've got 100. Okay? A little more difficult. We're stepping up how to find the extra points. You could, in theory, do this with the meal lips, same kind of thing. Okay, we're just stepping up what we're doing here. Next one, same idea. Where is it centered at? It's centered at the origin. So just to kind of make things a little easier to get going, centered at the origin, we have a vertex 0, negative 2, 0, negative 2. We have a vertex here on the y-axis. That means that it's going to open up and down like that. So we don't have our A from this. We have our B from this. So this gives us our B. And what comes first, the x squared or the y squared? The y squared does because it opens up. So I have the equation y squared over, and my B is 2, so this would be over 4. Or sorry, minus x squared over whatever a squared is equal to 1. I have that equation at this point. That's what I get from the vertex only. So I'm almost complete just from the vertex, right? Almost. I got to figure out what A is. Well, I have a coordinate. How many variables do I have, or how many unknowns do I have here? I have 3 unknowns, right? Y, X, and A. I have 3 unknowns, right? However, I know what I can substitute in for 2 of them, because if it passes through that point, these 2 points here are an XY coordinate. Plug those in for X and Y, solve for A. I have 3 unknowns. 2 of them are that. If I plug in those 2, I can figure out what the third one is. Okay? So, to figure out what A is, I plug in my X and my Y. So I have 6 squared over 4 minus 6 root 2 squared over A squared is equal to 1. So I have 36 over 4 minus 72 over a squared is equal to 1. 6 squared times 2. 6 root 2 squared is. So what is 36 over 4? This is 9. So subtract 9 from both sides. Negative 72 over a squared is equal to negative 8. Here's what's really cool. I love this because this is a proportion. Because all I have to do is put this over 1 and look what I have. I have a proportion. And when you have a proportion, you can swap the extremes or the means. You swap the diagonals. So I swap the negative 8 and the a squared. That gives me negative 72 over negative 8 is equal to a squared. You can do that. You can swap diagonals if you have a proportion. It makes life so much easier. I'm not multiplying both sides by a squared. I'm not dividing both sides by 8. I'm just swapping the two numbers. So divide that, 72 divided by 8. You get 9. So a equals 3. Although technically I didn't need a, I technically only needed a squared, right? So I can go back up here and make that 9. I have 3 unknowns. I could substitute in values for 2 of them and find the third one. All right. Okay, gotta loosen up for this one. This one is a combination of both of those that we just got done doing. It is not a pretty one. Okay. Our H and our K. So we have our vertex negative 4, 1 is here, or sorry, our center is here. So let me do this a little bit nicer. Negative 4, 1. We have a vertex at negative 7, 1. So we have this thing going on there. So I have, this is the center. This is a vertex point. So I know, hey, my vertex point is horizontally opposed. So I know it has to open this way. So I know I'm going to have another one over here. And I can figure that out, whatever. So what's the distance between here and here? Yeah, I go from negative 4 to 7, so the distance is 3, which means from that information, my A equals 3. My B, on the other hand, that's an issue I have. I don't know that. So using H and K, let's set up the equation we have. X plus 4 squared over 9 minus y minus 1 squared over b squared is equal to 1. That's the information we've gotten so far from just the vertex and the center. Center and the vertex gave us all that information. What don't we have? We don't have B. However, we now have the same situation that we just had in the last problem. We have an XY coordinate we can plug in for X and Y and then solve for B. So my X is negative 4 plus 3 root 7. So I plug that into there. Negative 4 plus 3 root 7 plus 4 squared all over 9 minus y is 13. 13 minus 1 squared all over b squared is equal to 1. Okay, negative 4 plus 4 gives me 0, right? So I have 3 root 7 squared. I squared that. 9 times 7 is 63, right? Yeah. So I have 63 over 9 minus what? Yeah, we'll get to that in a second. This is 13 minus 1 is 12, so I get 144 over b squared is equal to 1. Yeah, 63 over 9, what did you say it was? 7. Subtract 7 from both sides. Oh, you think you're so smart now, don't you? So 144 over b squared equals negative 6, because you subtract 7 from both sides. And once again, you do understand what I'm saying about, let's pause on this one for a second here. Proportions. A over B equals C over D. Proportions. This is a proportion. I have one fraction equal to another fraction, right? You can do lots of things to this to solve them. You can take both of them and flip them over if you want to do that. You can swap the means, you can swap the extremes. That's what I like to do. It's the same thing. A over C is equal to B over D. I can swap these two, or I can swap those two, or I can just flip the whole thing over. If I can set up a proportion, it makes it really easy to solve. So if I go back to this one, put it over 1, I swap the negative 6 and the b squared. So I get b squared equals negative 144 over negative 6. B squared is equal to 24. And you know what? I don't need b, do I? I need b squared. I'm not going to screw with it. I'm going to take b squared here and just put in 24 instead. And there's my equation. Yeah, I'm not going to take the square root and then square it back again. Because I'm lazy. Now, I'll freely admit it. You do know the mathematicians are a lazy lot, right? We were more than happy to do the required work, but we don't want to do any work that we can get away with doing shortcuts instead, especially when it comes to writing things. Okay, graphing. Okay. So, in order to graph a hyperbola, you need the same three things that you needed to graph an ellipse. You need center, A, and B. So my center is 0, 2. My A is 3. My B is 2. Go out 3 in each direction on the X, and up 2, and down 2. And then on the ellipse, we drew an ellipse to those points. For a hyperbola, put in a box using those 4 points to give you the length and width of your box. Draw your diagonals. The diagonals are your asymptotes for your curve. So this one, my vertex is here. This one, my vertex is here. There's my hyperbola. Yes. Okay. Questions? Okay, same thing on the next one. Ooh, wait a minute, I got a problem on the next one, don't I? What does it need to be equal to? 1. It's not equal to 1. First thing you do is add 5 to both sides. So you get, let's see if this works. There, give myself a little more room. So you add 5, so you get 20y squared minus 80x squared equal to 5. And then divide everything by 5. So I get 4y squared minus 16x squared equals 1. Oh crap, oh crap, oh crap. Yeah, good question. What do I do that? What is the form of the equation for hyperbola? It's x squared or y squared over a number, right? I don't have an over number, but I can change it to being over a number. Okay? This is the same thing as y squared over 1/4.
Oh, I hate that.
Minus x squared over 1/16 is equal to 1. Oh, you know that's on tape, right? Okay. So this one's going to suck for graphing, but you get the idea of what you're supposed to do here. What's my center? 0, 0. My center's the origin. That's nice. What is my A? Yeah, which is what? 1/4. What's my B? 1/2. So A is 1/4, B is 1/2, and it's centered at the origin. Well, let's do this. We're going to put it centered at the origin. Let's just say that instead of those being 1s and 2s and 3s, those are actually, let's make it 4s. So instead of being 1, 2, 3, it's 1/4, 2/4, 3/4. Can we do that? Can we all agree to that? We're going to change the scale. So if I go out 1/4 in each direction, I'm actually going out to here and here. If I go 1/2 in each direction, that means I'm going up 2/4 and down 2/4. And you put in your box. And then you put in your diagonals. And obviously that's close enough for government work. Which direction does it open? Yeah, it's Y. So where are my vertexes at? Remember my vertexes, we have to know where they are. They are important points. They're at the ends of the B's in this case. Okay. Questions? Okay, do C. Okay, so let's do this. Our center is at 3, -1. Our A is 7. Our B is 5. Because remember, the A's and the B's are still under X and Y, respectively. It's not first and second. It's what variable they're under. Okay, so I kind of screwed with this one a little bit to make it easier to work. So 3, 1, because these won't really fit well on here, I am going to make them go by 2s. So 3, -1, so that would be going 1.5 and 1, so that'd be here. And then 7 each direction. So let's see, 3 + 7, that'd be 10. 1, 2, 4, 6, 8, 10. Yep. And then up and down 5, so 1, 2. Okay. Which way does it open? Up or down or left or right? Which way does it open? Up and down because the Y's are first. Okay, here we go. So the last problem we have is probably the most challenging and actually not too bad. We have to do like we did with the completing the square for the circle. So first thing you want to do, x's and y's on one side, put the x's in the front, put the y's next, and leave spaces and put the constants at the end. So I add 12x to both sides. So I get 2x squared plus 12x. And I'm not going to worry about anything else. Well, actually, yeah. And then minus 7y squared plus 14y is equal to 17. And this is where it really gets a little sucky because completing the square really sucks if you have something in front of your x. Correct? If you have something in front of y, because technically completing the square has to be a single x in the front, right? And a single y squared. However, we are smart people. We have, even though our sleeves are short, we still have a trick or two up them. Here's what you want to do. What do you have in front of the x squared? A 2. Factor a 2 out of your x terms only, leaving a blank. So this is what it should look like. You should have 2 times x squared plus 6x blank. And then what am I going to factor out of my y's? A negative 7, because I want positive y squares. Negative 7, y minus 2y blank equals 17. Just giving myself some room. Okay, now I need to complete the square, and this is where things can get tricky if you're not careful. What do I put into here to complete the square? Plus 9, because half of 6 is 3 squared, I get 9. Okay. However, do I add 9 to the other side? I add 18 because I got to multiply times the 2 that's out front. Ooh. See, I said we had smart people in here. Okay. So what do I have here? I have a plus 1 because half of 2 is 1. I square it. But what do I add to the other side? Negative 7. Okay. 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 Do you know where I got the 1 from?
Oh, yeah.
Okay. Now, do you understand where I get negative 7 from? Because what do I actually have here? I have a 1 here times negative 7, so that means I need to subtract 7 from the other side. Okay. So I now have 2 times x plus 3 squared minus 7 times y minus 1 squared is equal to 28. What is it supposed to be equal to? 1. So divide everything by 28. So I end up with x plus 3 squared over 14, because the 2 and the 28 reduce, minus y minus 1 squared over 4, oh, that's so nice, equals 1.
Oh, I hate it.
Oh, yeah, I knew that was going to be a nasty one when I was doing it from the outside. I don't care, though, because we're smart people. We can do this kind of stuff. Okay, now for graphing purposes, our center is negative 3, 1. Our A is the square root of 14, which is approximately 3.75. Take it on your calculator to give you something to graph from. And our B is 2. So I go to the point negative 3, 1. My A is 3.75, so 1, 2, 3, and about a quarter, and 1, 2, 3, and about 3/4, and then up 2, and down 2, and there's my box. Put in my diagonals.
Oh, oops.
Which way does it open? Left and right or up and down?
Left and right.
Oh, poop.
That's a video.
Yeah, I know.
Dude, I don't
Not like the first time I would have screwed up. Negative 3, 1. Okay, there we go. My bad. Up and down 2. Let's see, 3 3/4. 1, 2, 3 3/4. Okay, and which way does it open? Left and right? B is always up and down, A is always left and right. And A is always under the X, B is always under the Y. Questions?